Alright, so in this video we're going to continue what we were discussing in class, and so I think we left off on an example similar to this one here, and so we're asked to evaluate a tangent of cosine inverse of -5/13, and what I've done over here is kind of written the definition that you have already in your notes, just so that we can refer back to this here in case we forget anything. And so the way I'm going to go ahead and start this problem is I'm going to start by saying that this right here is, I'm going to label that as theta. And so really off to the side over here, I'm going to say that theta is equal to cosine inverse of -5/13. And so what this means, again, if we rewrite this, we can rewrite this as cosine of theta equals -5/13 according to our definition that we defined in class. And so now we just have to ask ourselves, well, the domain was satisfied. I mean, x was between, this was our x, this here is considered to be our x value, and so it falls in between -1 and 1, so that all worked out. Now we just need to consider our theta, our y value, or our output. And so theta should equal something that falls between 0 and pi. And again, 0 and pi lies here, right? So we need to figure out, okay, well, where is this theta? Now, if you look at what we have, cosine is -5/13, and so we can choose between quadrants 1 and quadrant 2. So because cosine is negative, we can go ahead and just say that, oh, it's going to be in quadrant 2. And so if I go ahead and just sketch out quadrant 2, so let's see, here's my y-axis, and let me go ahead and sketch out the x-axis. Then again, we're going to have some point or some angle that we're going to create, and it's going to look something like this. So what we're going to go ahead and do is make some type of triangle right here. And just notice again, remember your definition of cosine. Your definition of cosine was x over r. So this is our x value, this is our r value, and so x would be this horizontal distance right here, so that's going to be -5, and then r is 13, and so what we need to figure out is what our y value is going to be. And again, just using the Pythagorean theorem, because this is technically a right angle, or right triangle, I mean, and we're going to use the Pythagorean theorem to go ahead and finish this problem off. So again, we're going to have -5 squared plus y squared is equal to, let's see, 13 squared. And again, this is going to give us 25 plus y squared equals 169. If I subtract 25 from both sides, I'm going to get that y squared is equal to 144. And then again, if I take the square root, I'm going to get that y is equal to plus or minus 12. Now we just have to decide, do we take the positive or negative? Well, we are in quadrant 2, so in quadrant 2, notice that we have to go up for y, so that means that it is positive. So we're going to go ahead and ignore this negative here, and we're just going to keep it as positive 12, and so we already know what y is. Well, if we come back to our problem, let me go ahead and change my color here. If we come back to our problem, we're going to have tangent of theta. Now let's think about theta and what theta was. Well, theta was this angle that was over here that I'm kind of shading in. So there's theta. Now by definition, tangent is defined to be your y over your x. And so again, if we just look at our triangle, we already know what our y is. Our y is 12, our x was -5. So therefore, tangent of theta is going to be 12 over -5. Or if you want to write it like this, we could just put we could just put the negative out in front and just write 12 over 5, -12 over 5. And this would be, again, this would be our final answer here.